Hello everyone. So in this lesson we're going to look at how to calculate the area under a curve. We have been given an equation here and that gives us this curve, and our question is to estimate the area under the curve between x equals 0 and x equals 3. So here's x equals 0, here's x equals 3. We're going to estimate the area beneath this part of the curve. So to do that we need to split the curve into trapeziums. So there we go, I have split this into 6 equal width trapeziums. We'll label these A, B, C, D, E and F. So we can find the area of each one and then add them all together to get the total area under the curve. Okay, so now we've got the 6 trapeziums. We'll start with A. Now to work out the area of a trapezium, you take the length here or the width here and you multiply by the mean length of those two sides. So that will be a half multiplied by the mean length of 5 and 6.4. So the area of A is equal to 0.5 wide multiplied by 5 plus 6.4 over 2, because that gives us the mean length, and that will give us the area of A. We'll come back and work these out at the end. So let's just do B. So for B, we know the width is 0.5. We multiply that by its mean length. Well, the first one we look at was the same as the last one, that's 6.4. We're going to add the length here, which is 6, and we're going to divide that by 2 to get the mean length. And then we work out C, D, E, and F. So I'll do those now. Okay, so I've calculated the area of trapeziums A to F. And all I need to do now to work out the complete area of that curve. So remember what we're trying to achieve here. We're trying to work out the complete area under the curve. So we're working out the area of this, plus the area of B, plus the area of C, plus the area of D, plus the area of E, and the area of F. So we're working out this complete area under the curve, or finding an approximation of it. So we found out each segment. All we need to do now is add those together to get the total. So we take this lot here, we add those together, and therefore the total area under the curve between x is 0 and x is 3 is 12.55. Okay, so we've done that one. So now we can see how we do this. Let's look at where we use it in another question. So here we have a question that says an object is moving, and then it says use the graph to estimate how far the object has travelled between 1 and 4 seconds. So like we did before, we draw some trapeziums and then we calculate the area beneath the curve. Now, depending on how accurate you want this, depends on how wide the trapeziums will be. You could draw them a whole 1 unit, or you could draw them half unit, or in some cases 1.5 units. This all depends on how accurate you want the answer to be. Sometimes the question will actually tell you to do 3 trapeziums or 4 trapeziums. So therefore you can work out the size that each one needs to be. In this case, we'll do them 1 unit in width. So we'll have 3 trapeziums. I'll draw those on. So there we go. We have got 3 trapeziums. So again, like before, we'll label these A, B and C, and then we'll work out the area of each. So what we have to do here is work out roughly this point going across. So I will call that about 54. And this point here looks around about 64. Now we do area B. Now remember, the height between A and B was 64. So we have that first. And now we're looking at the length of this line here, and that is around about 65. Now we start with 65 now, and the final one is up at 60. Okay, so we've worked those out. And now to find the total area under the curve between 1 and 4 seconds, we add those together, and it travelled 186 metres. Now before I get to the next part, let's look at the units. So we have got this height here is in metres per second. Okay, so think about what we're doing for a second. So this width here is in seconds. Okay, so this width here is in seconds, and we're multiplying it by this height, which is metres per second. So you've got seconds multiplied by metres per second. So this is now working out the units. So we have got seconds multiplied by metres per second. And if you cancel those two, you are left with metres, and that's why we've got the distance there. So the final sort of question here really is, do you think this is an overestimate of the area or an underestimate? Now, if you look carefully here, you've got a gap. There's nothing really in this one, and you've got a very small gap here. So the area we've calculated is a slight underestimate because it doesn't include the area missing in these gaps. Now, if we look at the previous question, we had some overestimates as well as underestimates. So that's it for calculating the area under curves. And as always, if you've got something from this, please like and subscribe. And I'll see you in the next video.